This is Chapter 3 for your dimensional analysis or dosage calculations. And again, it is a review of some basic math, so you need to be the judge of whether you need to review or not. It is on solving common fraction equations. As you'll soon find out, most of the dosage calculations that we do are going to be fractions, setting up fractions and then multiplying them throughout. And so common fraction equations are going to be solved by multiplying all the numerators and then divide the numerators by the denominators. The numbers in the equation may initially be reduced, which can make handling the numbers a lot easier using common denominators, which we talked about in the last chapter, to simplify the final multiplication and division. In this chapter, we will talk about using your calculators to solve the equations. You can also do these out manually, but you will be allowed to use calculators in your clinicals. The important thing is going to be concentrating only on the entries being done, not the numbers that register and change throughout the calculation. So in other words, you've really got to get the correct numbers, whether they be decimals or whatever they are, in the correct position of numerator or denominator and set up the problem accurately and then come up with your final end product. It is always a good idea to double check your calculator entries and answers as well as calculations performed manually. It just takes one mistake to hurt a patient. So make sure that you're double checking your work. When calculating dosages and you have a fraction equation, the end answer can be expressed as either a whole number or to the 10th or the 100th. I can't think of a situation where you would ever round to anything other than that. It does depend on the calculation being done, and as we go through you'll understand that. For example, if you're coming up with a drip rate, you can't give a tenth of a drop, so that has to be rounded to a whole number. But here's the rounding rule, and it's imperative that you memorize this rounding rule. If the answer is less than 1, you're going to round to the 100th place. You'll see why that is when we work with tuberculin syringes. If the answer is greater than 1, you either round to a whole number or to the 10th place. That depends on what you're calculating. When you're calculating kilograms, you always want to round to the 10th. You have a couple of options. You can either use the calculator throughout, or sometimes it's easier to do your initial fraction reduction just because you're working with smaller numbers, and then use the calculator for the final division. We do allow you to use your calculator here, so you can, that's certainly an option. Just make sure that you get your entries in correctly whenever you're using a calculator. Okay, so here's option 1. You multiply the numerators, and then you're going to divide by the denominators. You will remember that the numerators are on top and the denominators are on bottom. So in this particular equation, you've got 2 times 3 divided by 5 divided by 4, and your answer is 0.3. Now you may ask, would it be possible for me to multiply the numerators across the top? So 2 times 3 would be 6. Multiply the denominators. 5 times 4 would be 20. And if you calculate that out, 6 divided by 20 would give you the same answer. So yes, that is an option as well. Option 2 is where you divide the numerator 2 and the denominator 4 by 2. In other words, we are going to be reducing the fraction. And so we know that 2 will go into 2 once, and 2 will go into 4 twice. So all we've done here is just reduce the fraction, which then gives us the end result of 3 divided by, actually we can divide it by 10 if we multiply 5 times 2, and you come up with the very same answer. This isn't that big of a deal when we're using smaller numbers, but when you get into using the larger numbers, and you have larger numbers in your calculations, reducing the fractions can really be helpful. Now sometimes we have fractions that actually have numbers that have decimals in them. That is probably where most dosage errors occur. So we have to be either extremely careful when we enter them into the calculator, or we can get rid of the decimal points, and we did that in the last chapter. But I think there is a example here in a future slide. And here is basically talks about simplifying before calculating. You can simplify the numbers in a decimal fraction by eliminating the decimal points. So if you had 2.0 divided by 5, let's say 2.5. I'm going to change that. Sorry, hope you can see that. Then we would want to eliminate the decimal point, and what did we learn? We have to move it over the same number of spaces. So this would become 25, and since we don't have a place here, we've got 5, we would have to add a 0. And so that would eliminate the decimal point, and the fraction would still be equal to what we started out with by moving the decimal points over. Again, you got to make sure that you're entering the decimal points correctly, or your end result's not going to be correct, and you want to double check. Okay, so here is an example of option 1, where you multiply all the numerators as they are, entering the decimal point, and then dividing by your denominators. And that's, without turning the fractions into whole numbers. And the answer here, so what we do, it's kind of hard to see this right here, but it's 0.3 times 2.1 divided by 1.2 divided by 0.15. You can do that on your calculator, and your answer is going to come out 3.5. Ignore this right here, because 3.5, the 0.5 is not 5/100ths, it's 5/10ths. So I think that's a mistake. Or you can do option 2, where you get rid of your decimal points, and we've talked about that before. You can see here you've got the same problem, same equation, but what we've done is we have moved this 3 over 1, and so we have to do the same thing in the denominator. So that becomes 3/12, and in this one we have to move this over 2 places, so we also have to do the same thing in the numerator. So that adds a 0, and this one becomes this. Then you're working with whole numbers, which are a whole lot easier to work with. Then you could further reduce this one by, we know that 3 goes into 3 once, and 3 goes into 5 15 times. And we could probably reduce this other number, but then you end up just with 210 if you don't reduce further, over 60. and it's going to give you the same answer as what you got in the last. We could reduce this then by eliminating the zeros. Again, we're using some of those things that we talked about in the last lesson. And then you've got 21 over 6, whatever that turns out to be. And this is just showing the reduction of that fraction, except they went ahead and divided the 210 and the 15 by 5, so they ended up with this simplified equation right here. Here's another example of reducing the fraction and then using the calculator to divide the remaining numerator by the remaining denominators. So they've reduced 2 goes into 4 2 times, and 2 goes into 42 21 times, and then you end up with 21 divided by 2 divided by 3, or you could do 21 divided by 6. Again, this slide just emphasizes the fact that oftentimes you can reduce your large numbers dramatically by just reducing the fraction, as we've just done. And so that just makes the numbers easier to work with. When we're doing calculations, a lot of times you'll have multiple number equations, and that's what this next slide is going to be about, and it'll show you the 2 examples of how to work those. Here we've got 4 different fractions that we are working with, and so we can just multiply straight across. 60 times 1,000, don't really need to, times 1 is, we can leave that out, so times 6, and then divide it by, if you divide anything by 1, it's going to be itself, so we can forget that one. So we divide by 4, and then we divide by 1,000. And you're going to come up with your answer of 90. The next slide we'll see how we can reduce the fraction and make that. Okay, so in this one we can cancel out, we can really reduce this because we can, this 1,000 and this 1,000 can cancel each other out. Has to be in the numerator and the denominator, but they can be canceled out completely. So then what you're left with is just your 60 times your 6, as you can see right over here. On the bottom, we're just left with 1 times 4 times 1. So because we want to have something in the denominator, we've got our 1 here, times 4 is all that's left. That could be further reduced because we could, in this example, 2 goes into 4 2 times, 2 goes into 6 3 times, so then you end up with 60 times 3 divided by 2. Now I guess we could further reduce that if we wanted to. 2 goes into 2 once, 2 goes into 60 30 times, and so we'd end up with 30 times 3, which is 90. And that's what we came up with in the last one. So you can see that there's a lot of reductions that can be done that make it a lot simpler. And here's the answer of 90. You've heard the old saying in woodworking, it also is true if you quilt, which I do, and you want to measure twice and cut once. Because if you measure once, sometimes you have to cut twice. So measure twice, cut once, double check all your calculator entries, your calculator answers, and your manual calculations. So your patients will be safe.